Okay. This is a 3 equations, 3 variables. It says solve by elimination or substitution. With 3 equations and 3 variables, it has to be done by elimination. I did mention in the lesson, if you're solving equations with x, y, and z, you want to try to avoid eliminating z. I know it seems pretty tempting because of that right there, but if in the case that you have to solve in terms of a parameter t, it makes it more difficult if you've eliminated z right off the bat, so I would avoid eliminating z. So I'm going to try to eliminate x. I notice here that if I multiply the bottom equation by -1, then I get 3x plus, this is the middle equation here. The bottom equation becomes -3x minus 4y plus 2z equals -5. When you add those together, you get -2y plus 3z equals -7. Now, I want to do the same thing to 2 different equations and try to eliminate x. So if I took these top 2 equations here, for x we have 4x and 3x, the least common multiple would be 12. So I want to get one of them to be -12x and the other one to be +12x, that way I can eliminate x. So if I multiply this top one by -3, for example, the middle one by +4, that gives me the equations -12x plus 9y plus 3z equals -30, and then 12x plus 8y plus 4z equals -30 or -8. Yeah, these together, the x's are gone. You get 17y plus 7z equals -38. So now we have 2 different equations with y and z. We have this one here, we have this one here, so those need to be combined and solved as a system of equations. So I'm going to try to eliminate z here. You can eliminate z as a second step, but not just in the original problems here. So between 7 and 3, the least common multiple is 21. So I'm going to multiply top equation by 7, the bottom equation by -3. So the top equation becomes -14y plus 21z equals -49. The bottom equation here becomes -51y minus 21z equals +114. If you add those, z's are gone. -65y equals 65, so y equals -1. So now you go back up a step and solve for z. So if you take any one of these middle equations in their original form, this one for example, you plug in the -1 right there for y, that turns into -17 plus 7z equals -38. You add 17 to both sides, you're going to get 7z equals -21. So z equals -3. Now you're going to want to go back up to the original equations and choose one of them, plug in z and y, and solve for x. So middle equation here, for example, 3x plus 2, and then y equals -1 plus z equals -2. So 2 times -1 is -2. If you combine -2 with -3, you get -5. So we have 3x minus 5 equals -2. Add 5 over, and you get 3x equals 3. So x equals 1. So I don't have to search around your whole paper to try to find answers. You do need to represent your solution as the order pair 1, comma -1, comma -3. Question 2 starts the same way. Here's question 1. You want to try to avoid eliminating z. right off the bat, I notice here that we have positive and negative y, so if we just took these top two equations and added them straight up as they are, we would get 3x plus 9z equals 0. That's a result of those two equations there added together. Now, if we combined the top and the bottom one, but multiplying the top by 4, then that's going to give 4x minus 4y plus 20z equals negative 8. So 4x and 2x, that makes 6x. Negative 4y, positive 4y cancel. That makes 20z minus 2z, that's 18z. And then 4 times negative 2 is negative 8. Negative 8 plus 8 is 0. So now we would want to solve this one, system of equations, by multiplying by negative 2. We get negative 6x minus 18z equals 0. So we end up with 0 equals 0. That's an indication of infinitely many solutions. So, if there are three equations, three variables, the convention is to let z equal t. This is the parameterization. Let z equal t. And let me go back and solve for the other two variables in terms of t. So we know that z equals t, so go back up to here into one of these equations and solve for x. So if we take this middle and put a t in here for z, we're going to get 6x plus 18t equals 0. If you subtract the 18t over, you get 6x equals negative 18t. If you divide by 6, you get x equals negative 3t. So you know what z equals, we know what x equals. Now we got to go back and find out what y equals. So going up to one of the original equations, I'm going to choose this middle equation here. So 2 times x, where x is negative 3t, becomes 2 times negative 3t. We don't know what y equals. We know that z is equal to t. 2 times negative 3 makes negative 6t. Negative 6t plus 4t is negative 2t plus y equals 2. You add the 2t over, you get y equals 2t plus 2. So your parameterized solution is negative 3t, comma, 2t plus 2, comma, t. And, same type of thing. This one's a little bit easier to solve because it only has two equations, two variables. We want to try to eliminate one of the variables. I'm going to try to eliminate y. So I'm going to multiply this top one by 3, bottom one by 2. We're going to get 24x minus 6y equals 15. Negative 24x plus 6y equals 14. We end up with 0 equals 29. That's not true. There's no variables to solve for. This is an indication of no solution. The system of equations has no solution. Okay, there's just two different row operations we have to perform here. This bar, I think I mentioned this in the lesson, some textbooks use a bar right here to represent where the equal sign would be. That's all this means. This is an augmented matrix. These would all be coefficients in front of variables. These would be the numbers after the equal sign. This vertical bar just means that's where the equal sign is. Anyway, first row operation. You multiply every entry by in row 1 by negative 3 and add that to row 2. And that replaces the entries in row 2. So negative 3 times 1 is negative 3 plus negative 1, negative 4. Negative 3 times negative 4 is 12. 12 plus negative 6 is 6. Negative 3 times 3 is negative 9 plus negative 6 is negative 15. And negative 3 times negative 7 is 21 plus 8 is 29. So that's this row operation. Now we can do the same one here, or the second row operation using this same matrix. So we can do 2, row 1, add that to row 3, and that's going to equal row 3. So 2 times 1 is 2, plus negative 7 is negative 5. 2 times negative 4 is negative 8, plus negative 5, negative 13. 2 times 3 is 6, plus 6 is 12, and 2 times negative 7 is negative 14. Negative 14 plus 8, negative 6. Top row stays the same. And that's all you were supposed to do on question 4. Question 5. First we need to check that this multiplication is even possible. This matrix has 2 rows and 3 columns, so it's a 2 by 3. This matrix has 2 rows, 3 rows, and 2 columns. So it's a 3 by 2. These inner dimensions here are the same, so that means the multiplication is possible, and it's going to result in a 2 by 2 matrix. So this is where our 2 by 2 matrix is going to come. This first entry in the top left corner is a result of this top row in this first column. So if we go down the column and across the row, we're going to have negative 3, and then negative 64, and 35. So that's negative 32. This entry right here comes from the bottom row. It's still the first column. So going across the bottom row down the first column, we're going to have negative 6 plus 48 minus 49. That's going to be negative 7. This entry right here is top row, second column. So across the top row down the second column, it's going to be 30. 3 times 10, and then negative 24 is negative 8 times 3, and then minus 35. So that's negative 29. This entry right here is the bottom row, second column. So 6 times 10 is 60. 6 times 3 is 18. 7 times 7 is 49. We get 127. Okay, question 6 is finding the inverse of a 2 by 2 matrix. Pretty straightforward. The formula is 1 over AB minus BC. And switch the place of D and A, switch the sign. So this is going to be 1 over A times D, or these two multiplied, that's 6. Then we subtract those two multiplied, that's subtracting negative 1. So now we switch the place of A and D, so this is negative 2 here to negative 3 here, and then we switch the sign of each of these. That becomes a positive 1. That becomes a negative 1 right here. 6 minus negative 1 is 7. And that's the inverse. Question 7 is to solve a system of linear equations using matrix algebra. If you solve it any other way, even if you get the answer right, you don't get credit for the problem. So, matrix algebra is to set up a matrix equation. And then this is what we need to get by itself, this matrix right here. The only way to cancel the matrix in front of it is to multiply by the inverse. So if this is matrix A, that's matrix X, that's matrix B. We're going to need to multiply it by the inverse. Because that'll cancel that. So X is equal to the inverse of A times B. Well, if you look closely, this matrix right here, 3, -1, 1, -2, that's the matrix from question 6. We already found the inverse. The inverse is right here. So according to this, we take the inverse and multiply it by matrix B. This is matrix B right here. And you leave the 1/7 out of it. So this entry in the top of this matrix coming across the row, down the column. -2 times -1 is 2. And then 1 times 12 is 12, 2 plus 12 is 14. Now, this entry in the bottom part of this matrix comes across the bottom row down the column, so -1 times -1 is 1. -3 times 12 is -36. That makes -35. Now you take this 1/7 and multiply it in there. 14 times 1/7 is 2. -35 times 1/7 is -5. So the solution is 2, -5. Finding a 2x2 determinant, it's just AD minus BC, so it's 5 times 5, and then 3 times -7, -21, so that becomes plus, and you get 46. Question 9, write this as a matrix, or write the matrix equation as a system of equations. It says do not solve. I don't care what x, y, and z equal. Just write this as a system of equations. Remember, all of these are coefficients. This tells what the variables are going to be. So this top row becomes 1x plus 4y minus 3z equals -21. Middle row becomes -5x minus 3y plus z equals 20. Bottom row becomes 8x plus y plus 5z equals -13. That's all I was asking. Pretty easy on that one. Okay, question 10. This is kind of a big one here. Trying to find the determinant and then the inverse. So, to find the determinant of a 3x3, it's best to choose a row or column that contains a 0. This column right here, for example. So, we're going to expand down this column. I'm going to choose 2 as my first cofactor, cross it out, minor matrix, then it's 2, 4, 5, 6. If you're going down this first row, the pattern is plus, minus, plus, so we're going to subtract the next cofactor. But since the cofactor is 0, that just means that middle piece disappeared. Now we're going to, again, the pattern is plus, minus, plus, so we're going to add the next number of that column. So if you cross out the row and column containing it, you get 3, -1, 2, 4. So this is just, these vertical bars mean this is a determinant. 2 times 6 is 12, and then you subtract the other cross product. 5 times 4 is 20. That's 2 times -8, and it gives you -16. Over here, 3 times 4 is 12. 2 times -2 is or 2 times -1 is -2. So minus negative is plus, so this is -16 minus 28. So that's -44. That's the determinant. And the inverse has to be found this way. You take the original matrix, and set up this. And the point is to make the left side look exactly like the right side. And once you do that, by performing row operations, you're going to be changing this right side into different numbers, whatever those turn into at the end. Once the left side looks like this, so it's going to be your inverse. So the first problem is we should have a 1 right here and the zeros underneath it. So the first thing I'm going to do is to try to get this entry right here to be a 0. You can do that simply by adding row 1 and row 3. So row 1 plus row 3 equals row 3. So 2 plus negative 2 is 0, 3 plus 5 is 8, negative 1 plus 6 is 5. 1 plus 0 is 1, 0 plus 0 is 0, and 0 plus 1 is 1. At the same time, this should be a 1 right here. So I'm going to take 1/2 times that by row 1, and that's going to equal row 1. So 1/2 of each of these values, that's going to give me 1, 3 halves, negative 1/2, 1/2, 0, 0. Row 2, that's a 3. Row 2 stays the same. And the next thing we need to get is, this should be a 1. So we could do 1/2 times row 2, and that's going to equal row 2. So this is going to give you, in the row 2, 0, 1, 2, 0, 1/2, 0. Next, we need to get this here to be a 0. So if you multiply row 2 by negative 8 and add that to row 3, so negative 8 times row 2 plus row 3 equals row 3. So negative 8 times 0 is 0. 0 plus 0 is still 0. Negative 8 times 1 is negative 8 plus 8 is 0. Negative 8 times 2 is negative 16. Negative 16 plus 5 is negative 11. Negative 8 times 0 is 0 plus 1 is 1. Negative 8 times 1/2 is negative 4 plus 0 is negative 4. And then negative 8 times 0 is 0 plus 1 is 1. Okay, the next problem is in row 1 right here. This should be a 0. So I'm going to multiply row 2 by negative 3/2 and then add that to row 1. So negative 3/2 times row 2 plus row 1 equals row 1. Alright, so negative 3/2 times 0 is 0. 0 plus 1 is 1. Negative 3/2 times 1 is negative 3/2. Plus 3/2 is 0. We pay attention here. Negative 3/2 times 2. Let me write that down. Negative 3/2 times 2 is negative 3. Because the 2's cancel. So that's what we're adding to negative 1/2. So we have negative 3 plus negative 1/2. That's negative 7/2. And here we have negative 3/2 times 0, which is 0. 0 plus 1/2 is 1/2. Negative 3/2 times 1/2 is -3/4. -3/4 plus 0 is -3/4. And then -3/2 times 0 is 0. 0 plus 0 is 0. So we need to get this, now we need to get this to be a 1. So I'm going to multiply -1 11 times row 3. That's going to equal row 3. 0, 0, 1. This becomes -1 11th, 4 11ths. -1 11th. And now this should be a 0. So I'm going to multiply row 3 by -2. -2 times row 3, add that to row 2, that's going to become row 2. -2 times 0 is 0, 0 plus 0 is 0. -2 times 0 is 0, 0 plus 1. Well, -2 times 1 is -2 plus 2 is 0. -2 times -1 11th is -2 11ths plus 0 is -2 11ths. -2 times 4 11ths is -8 11ths, and now we have to add that to 1/2. That's going to have to be multiplied by 11 over 11 over here, 2 over 2. So it's -16 20-seconds plus 11 20-seconds. That's -5 20-seconds. And then -2 times -1 11th is 1 11th, or -2 11th. Positive 2 11ths rather. -2 times -1 11th is 2 11ths plus 0 is 2 11ths. And finally, this -7/2 right here needs to be a 0. So we're going to multiply row 3 by positive 7/2. So 7/2 times row 3 plus row 1 equals row 1. Seven halves times 0 is 0. 0 plus 1 is 1. 7/2 times 0 is 0. 0 plus 0 is 0. -7/2 times 1, or 7/2 times 1 is 7/2 plus -7/2 is 0. 7/2 times -1 11th right here is -7 20-seconds. We have to add that to 1/2. So if we multiply this by 11 11ths, we're going to get -7 20-seconds plus 11 20-seconds. That's 4 20-seconds, which is 2 11ths. And then 7/2 times 4 11ths is 28 20-seconds, and now we have to add that to -3/4. 28 22nds, that's 14 11ths. So multiply this by 11, multiply this by 4, so we get negative 33 44ths. Over here we get 56 44ths. Let's see. It's 23 44s. So that goes right here. 23 44ths. And finally, 7/2 times row 3, that's right here, that's negative 7 22nds. We have to add that to 0, which is negative 7 22nds. And that's the inverse right there. Alright, using Cramer's rule here to solve the system of equations. Cramer's rule is using a bunch of determinants. If it's two equations with two variables, you need a D determinant, you need a D sub x, and you need a D sub y. Determinant D is just determinant of the coefficients. That's going to be 6 minus negative 1. 7. D sub x is the determinant where the x column has been replaced with these numbers negative 1 and 12. The y column stays the same. So this determinant is 2 minus negative 12, which is 14. D sub y means the y column has now been replaced with these numbers negative 1 and 12. And the x column stays the same as it originally was. This determinant is negative 36 minus negative 1, which is negative 35. So Cramer's rule says x is equal to d sub x over d, and y is equal to d sub y over d. So d sub x is 14 divided by 7, that's 2. D sub y is negative 35 over 7, that's negative 5. So the solution is 2, comma negative 5. So question 12 says, solve a system using an augmented matrix and reducing the augmented matrix to row echelon form as Gaussian elimination. So the augmented matrix looks like this. So we need to get 1 along this main diagonal and 0s underneath it. That's row echelon form. So we're pretty close actually. We have 1, 0. This should be a 0 right here. So if we multiply row 1 by negative 1 and add that to row 3 and make that equal to row 3, that makes a negative 1 here, plus 1 is a 0. That makes a negative 1 times negative 2 is 4. 4 plus 1 is 5. Negative 1 times 1 is negative 1 plus 3 is 2. And then negative 1 times 1 is negative 1 plus 8 is 7. Okay. So we have 1, 0, 0. This should be a 1, which it already is. That means that should be a 0. So the next row operation would be to multiply row 2 by negative 5 and add that to row 3. That's going to equal row 3. Because we want to get a 0 right here. So Negative 5 times row 2 makes negative 5 times 0, which is 0. 0 plus 0 is 0. Negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times 2 is negative 10, plus 2 is negative 8. Negative 5 times 5 is negative 25. You know what, I goofed up. That shouldn't be a 5. Yeah. Hold on now. Let me go back and do this row operation again. Negative 1 times negative 2 is positive 2, plus 1 is 3. Just check the other ones here. Negative 1 was a 7. Okay. Alright, that changes things. I was thinking to myself, this isn't working out nicely, but we're not going to multiply by negative 3. Negative 3 times row 2. We're going to add that to row 3. That's going to equal row 3. So we do 0 there. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 2 is negative 6 plus 2 is negative 4. Negative 3 times 5 is negative 15 plus 7. That's negative 8. And we're actually done. This bottom row represents the equation negative 4z equals negative 8. That means z has to equal 2. This middle row represents the equation y plus 2z equals 5. And if we know that z is 2, 2 times 2 is 4. If you subtract 4 on the other side from 5, you get y is equal to 1. This top row represents the equation x minus 2y plus z equals 1. Now y is 1, so this makes negative 2. Z is 2. Negative 2 plus 2 is 0, so x is equal to 1. So we get the solution 1, comma 1, comma 2. Okay, question 13. A man has 14 coins, all of which are dimes and quarters. So I'm going to have a variable d and a variable q. And he has 14 total coins, so d plus q is equal to 14. There's one equation. If the total value of his change is 275, how many dimes and quarters does he have? Well, a dime is worth 10 cents, so 0.1 times d. Quarters were 25 cents, so 0.25 q. That's equal to $2.75. Each dime is worth 10 cents, so the total value of all the dimes is 10 cents times the number of dimes you have. Total value of a quarter is 25, so the total quarters, or the value of all of his quarters is 25 cents times the number of quarters. Add that together, it should be 275. Now I'm going to multiply this bottom equation by 100. So we don't have to use decimals. This is going to be 10d plus 25q equals 275. And then I'm going to multiply this top equation by negative 10. That's negative 10d minus 10q equals negative 140. Add this up and we get 15q. And then 275 minus 140 is 135. And if you divide by 15, 135 divided by 15 is 9. So it's 9 quarters. Well, he only has 14 total coins. That means he has to have 5 dimes. So 5 dimes, let's just check this. 5 dimes, that's 50 cents. 9 quarters is $2.25. If you add that up, that's just $2.75. All right. What are the concentrations of sulfuric acid in the original container? So he has two large containers. The question here is, what are the concentrations? And so since that's our question, we can assign that to be our variables. We can let X be the concentration of container 1. We can let Y equal the concentration of container 2. So if we blend 300 milliliters of the first solution, which has a concentration of X, so that's 300X, to 600 milliliters of the second solution, which has a concentration of Y, that's going to give us 900 milliliters that has a concentration of 15%. But if you only blend 100 liters of the first solution that has a concentration of X, plus 500 milliliters that has a concentration of Y, that's going to give you 600 milliliters. That's 0.125% acid. And so there's your system of equations. 900 times 0.15 is 135. And 600 multiplied by 0.125, that's 75. So we can multiply this bottom equation by -3. That's going to let X cancel out. That makes -1500 plus 600. That's -900 Y. And then -75 times 3 is -150, or -225. And then if you add that to 135, you're going to get -90. Divide by 900, 90 divided by 900 is 1/10. So 1/10, that's 10%. So container 2 is 10% concentrated with sulfuric acid. So now that we know the value of Y, go back and solve for X. So if we plug in a 1/10 right here, for example, 1/10 of 600, it's going to be 60. So if you subtract 60 from 135, you're going to get 75. So 300X equals 75. Divide by 300, and you're going to get 0.25. So container 1 is 25% concentrated with acid. Question 15. Find the partial fractions. So we need to factor the denominator. X times x minus 4 has two partial fractions because there are two unique factors in the denominator. If you multiply both sides by the LCD, that's going to result in the equation x minus 12 equals a times x minus 4 plus b times x. So there's two convenient values we can choose. One would be positive 4, the other one would be 0. So if we let x equal 4, or we can let x equal 0, that's going to help us solve for these values here. So if x equals 4, 4 minus 12 is -8. 4 minus 4 is 0, that means the a term disappears. 4 times b is 4b, so b equals -2. Now over here with x equals 0, 0 minus 12 is -12. 0 minus 4 is negative 4 times a is negative 4a, and 0 times b is 0. Divide by negative 4, we get a equals 3. So the partial fractions are 3 over x plus negative 2 over x minus 4. Now here, the form of the partial fractions is going to be a over x. That takes care of this factor of x, but x minus 1 is repeated 3 times, so we have to have 3 more pieces. So we have x minus 1 squared, and x minus 1 cubed. So again, multiply the entire thing by the lowest common denominator, x times x minus 1 cubed. If this multiplies all the way to this original equation, the denominator cancels out completely, and you're left with x squared plus 1. If the denominator multiplies over here to the a term, the x's would cancel, so it's a times x minus 1 cubed. If the LCD multiplies over to the b term, x minus 1 cancels with one of these x minus 1s. So it would be b times x minus 1 squared. If this LCD multiplies to the c term, x minus 1 squared, there's 2 of those, so that'll cancel with 2 of these x minus 1s. So c times x minus 1. And finally, when the LCD multiplies to the d term, the x minus 1 cubes cancel out. So it's d times x. Okay. So, if we let x equal 1 as a convenient value, that will cancel the a term, the b term, and the c term. That allows us to solve for d. So if x equals 1, 1 squared is 1 plus 1 is 2. 1 minus 1 is 0, so that term's gone. 1 minus 1 is 0, so that term's gone. 1 minus 1 is 0, so that term's gone. X is 1, 1 times d is 1d. So right off the bat we get d is equal to 2. Another convenient value would be 0, because that'll cancel d, that'll cancel c, and that'll cancel b, allowing us to solve for a. So let x equals 0. 0 squared is 0 plus 1 is 1. 0 minus 1 is negative 1 cubed, is negative 1 times a is negative a. That means a equals negative 1. All the rest of the terms would have disappeared. B times 0 was 0, so that term is gone. C times 0 was 0, and D times 0 is 0. So we have 2 of our values we're searching for. We're out of convenient values of x, so now we just have to choose random values of x and also allow a and d to equal these 2 terms. So I'm going to let x equal negative 1, a equal negative 1, and d equal 2. So negative 1 squared is 1, 1 plus 1 is 2. A was negative 1, x was negative 1. So negative 1 minus 1 is negative 2, cubed is negative 8. Negative 8 times negative 1 is 8. We don't know the value of b, but x was negative 1. So negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times negative 1 is negative 4 times b. That's negative 4b. We don't know the value of c, but we are letting x equal negative 1. So negative 1 minus 1 is negative 2 times negative 1 is 2. 2 times c is 2c. We know that d is 2, and we're letting x equal negative 1. 2 times negative 1 is negative 2. 8 combined with a negative 2 is 6. If you subtract 6 over, we get negative 4 equals negative 4b plus 2c. Okay, problem is we have one equation with 2 variables. That's not going to work, so we have to do this again and choosing another value of x. I'm going to let x equal 2 this time, and a equals negative 1, d equals 2 again. Okay, so if x equals 2, 2 squared is 4 plus 1 is 5. a is still -1, but this time x is 2. 2 minus 1 is 1 cubed. 1 cubed is 1. 1 times -1 is -1. We don't know b, but we're letting x equal 2. 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 times b is 2b. Still don't know c, but again, x is 2. 2 minus 1 is 1. 1 times 2 is 2. 2 times c is 2c. And then d is 2. X is 2. 2 times 2 is 4. -1 plus 4 is 3. If you subtract 3 from the 5, you get 2 equals 2b plus 2c. So we take these two equations now. So I'm going to take this -4 equals -4b plus 2c. We solve this as a system of equations. So if you multiply the bottom equation by -1, that changes that to plus, that changes that to plus, changes that to minus. So the c's are gone. We get 6 equals 6b. So b is equal to 1. If b is equal to 1, then 1 times 2 is 2. If you subtract 2 from this 2, you get 0. So you have 2c is equal to 0, which means c is equal to 0. b is equal to 1. a is equal to -1. And d is equal to 2. So the partial fractions are -1 over x plus 1 over x minus 1. C was equal to 0, so that disappears. Plus 2 over x minus 1 cubed. Those are the partial fractions. Okay, question 17. Solve a system of nonlinear equations. We can solve this using substitution or elimination, either one. So I'm going to do substitution on this one. So if we take this bottom equation and solve it for y, we're going to get y equals 3x minus 5. So if you plug that into there, we're going to have 6x. Instead of plus y squared, it's going to be 3x minus 5 squared. That's equal to 10. 3x minus 5 squared is 9x squared minus 30x plus 25. So if we set this equal to 0, that should be plus 15 right there. I'm going to factor out a 3. Divide by the 3, kind of just gets rid of it. So 3x squared minus 8x plus 5. So we need to factor that. 3 times 5 is 15. We need two numbers that now add to -8. That's going to be -3, -5. So this is going to factor. So x minus 1 times 3x minus 5. That means x is equal to 1, and x is equal to 5/3. So if x equals 1, 3 times 1 is 3 minus 5 means y is -2. If x is 5/3, 3 times 5/3 is 5. 5 minus 5 is 0. Okay, question 18 is just like 17. I'm going to solve this bottom equation for y. It's going to be 3x minus 10 Now take that and substitute it in there. We're going to get x squared plus 3x minus 10 squared equal to 100. So combining some like terms, and factoring out a 10x, we get x is equal to 0 and x is equal to 6. Well, if x is equal to 0, 0 minus 10 means that y equals negative 10. If x is equal to 6, 3 times 6 is 18 minus 10 is 8. There you go.